Okay, so this is the second day of section 5.3. I want to wrap up this Kaiser family problem. If you didn't do so already, pause, set up your own tree diagram because you should be good with that by now, okay, or improving. Here's my tree diagram. I multiplied everything across already just so we save some time. So first we want to find the probability that this person describes his or her grades as good. So our good would be these three. So the probability that they describe their grades as good, we're going to have 0.1258 plus 0.4216 plus 0.1092. So the probability that we describe our grades as good should be 0.6566. All right, now part C is saying, given that this person describes his or her grades as good, what's the probability that they are a heavy user of media? So what's the probability? So given, let me back it up. Given that they describe their grades as good, what's the probability that they're a heavy user of media? That means that good goes in the bottom, and we want probability that they're good and a heavy user. Good grades, heavy user of media in the numerator. Good grades and a heavy user of media is right here, 0.1092. And we're going to divide that by this, probability of a good grade, 0.6566. And when you divide those down, you should get 0.1663. Okay, now the next objective in the last part of section 5.3 is to talk about complementary events. So when events are complementary, right, it's not like, oh, I like your outfit today. Nope, not that kind of compliment. Complementary events are when it's everything but the event you're talking about. So if I say, what's the complement of it being a rainy day? It could be a snowy day, it could be a foggy day, it could be a misty day, it could be a sunny day, you know, all those other things, right? When we're talking about at least one of something, okay, what you want to do is you want to calculate the probability of none of those events happening, and then subtract that from one, and you'll get everything else already done. All right, so for instance, if I have 10 kids in class and I have 5 boys and 5 girls. If I say, what's the probability of picking 3 kids and at least one is a girl? It could be 1 girl or 2 girls or 3 girls. So instead of doing that, because you have to do the probability of 1, the probability of 2, the probability of 3, and add them up, what you can do is you can say, all right, what's the probability of no girls? Because 100%, 1, minus the probability of no girls is going to leave me with the other 3 situations already added up, because none, 1, 2, or 3 is all of the scenarios, right? So for instance, we're actually going to come back to number 9. Let's do this silly example. All right. The probability of the tooth fairy forgetting to visit a toothless child on any given night is 0.20. Ask your parents. Promise, it is tough to remember. Okay, so the probability of forgetting to visit is 0.20. Okay, if 4 newly toothless children are randomly selected, what is the probability that the tooth fairy will forget to visit at least one of them on that given night? Okay, now forgetting 1 kid would mean you could forget 1 or 2 or 3 or 4. At least 1 are these scenarios. So what we're going to do, instead of doing at least 1, we're going to do 1 minus the probability that there's none that are forgotten. All right. So we're going to have 1 minus the probability of not being forgotten. If being forgotten is 0.20, then the probability of not forget is 0.8. So we're going to have 0.8, and then there's 4 kids. So it's 0.8 multiplied with itself 4 times, So it's to the 4th power. Okay, don't forget, don't forget, don't forget, don't forget. And that will leave us with all of these probability scenarios already added up for us. So 1 minus 0.8 to the 4 gives us 0.594. Telling you, talk to your parents. It's tough, 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 tough. All right, now here's a neat example about false positives, which is so current right now, right? False positives, false negatives, all the testing. But we're going to talk about strep, okay? So when given to a person who has no strep antibodies, meaning they don't actually have strep, a rapid strep test has a probability of 0.004 of producing a false positive, meaning it says they have strep throat when they really don't. If a clinic tests 200 people who don't have strep, what's the probability that at least one false positive is going to occur? So, at least one false positive out of 200 means 1, 2, 3, 4, 5, all the way up to 200 people could test false positive, all 200. We do not want to calculate that on our own. Absolutely not. So instead, all right, so if we have the probability of a false positive is 0.004, okay, that means the probability of not a false positive is 0.996, 1 minus 0.004, okay. Probability of at least one false positive, we're going to do 1 minus the probability of no false positives. So it's going to be 1 minus, not a false positive is 0.996, but we have to raise it to what power? The 200th power, because there were 200 people tested. Okay, and when you subtract this, you actually probably get a much larger number than you would expect. But think about it. It's a 0.4% chance that someone's going to get a false positive, and there's 200 people being tested. So at least one of the 200 having a false positive is very likely. Okay, which ties into everything that's going on right now in the world with coronavirus. That it is, even though it's a really small chance of a false positive, when you look at lots of people and all the scenarios of how it could run down, the probability is actually pretty great. All right, with this one, okay, the first trimester screen is a non-invasive test given in the first trimester of pregnancy to see if there are specific chromosomal abnormalities in the fetus. According to a study published in the New England Journal of Medicine in November 2005, approximately 5% of normal pregnancies are going to receive a positive test. If 100 women with normal pregnancies are tested in the first trimester screen, what's the probability that at least one woman will receive a positive result? So, probability of positive is 0.05, which means probability of negative is 0.95, or not positive, if you prefer to write not positive. We want the probability of at least one positive. We're going to do 1 minus the probability of no positives or negative. So it's 1 minus, not positive is 95%, and we raise it to the 100th power because there are 100 women. And you get a 0.9941 probability. It's pretty likely. Super massively likely. All right. So let's just talk about this guy. If you're talking about 2 dice being rolled, the probability that their sum is more than 4 means their sum could be 4, 5, 6, 7, 8, 9, 10, 11, and 12. Oh my goodness, please don't ever try to do this by hand of all of the scenarios. All right. Instead, if we think about dice, right, if we want a probability of sum 4 to 12, at least 4 or more than 4 is 4 to 12, we can do 1 minus the probability. What are the other sums? Dice can be a 2 or a 3. All right, so the ways you can roll a 2 is just you can get a 1, 1. The ways you can roll a 3 are a 1, 2, or a 2, 1. So there are 1, 2, 3 ways you can roll a 2 or a 3. So I'm going to do 1 minus 3 out of 2 dice are 36 options, 36 outcomes. So that'll leave me with 33 out of 36. It added up all of these scenarios for me, or 11/12. And that's my answer. Okay, good job today. See you soon.